Differential Equations Section 1 Tangent Fields. Video 4 Isoclines. An isocline is a curve that joins a set of points that have the same derivative. You might think of them a bit like contour lines on a map. So if we have a contour, it joins places that have the same altitude or height. And that allows us to look at a contour map and to be able to visualize what the landscape would look like, because we know what it means when different areas are joined together. It means that they're all at the same height, and we can start to visualize where there are hills and where are the valleys. Now, isocline has the prefix iso, which is a Greek prefix which means the same or equal. And you've come across this before. If you've ever watched a weather forecast, you might have seen them use isobars. And an isobar joins places with equal pressure. And you may also recognise it from the word isosceles for a triangle that has two sides the same. So isocline is literally joining points that have the same incline or gradient. So all of the points that have the same derivative, you can join them with an isocline. Let's have a look at an example. Sketch the isoclines on the tangent field for dy by dx equals 2y for the points with gradient 1 and gradient negative 2. So this is the example that we were looking at in previous videos, and here's the tangent field for it. And in this case, in order to find the isoclines for gradient 1 and gradient negative 2, well, for gradient 1, I want dy by dx be equal to 1, so that means that 2y is equal to 1, which means that y is equal to a half. And if you look here on the line y equals a half, all of these lines, these little lines in the tangent field, have gradient of 1. For negative 2 then, I need to solve 2y equals negative 2, and that means that y is negative 1. So just here on the line y equals negative 1, I've got all of these lines on the tangent field have gradient of negative 2. So here's the sketch of my isoclines. So this is the isocline y equals a half, and this is joining points with gradient 1, and this isocline is y equals negative 1, and this is joining the points that have gradients of negative 2. And in fact, on this particular tangent field for the differential equation dy by dx equals 2y, all of the isoclines are going to be horizontal lines. We're going to see other examples in the next video where the isoclines are slightly more interesting. Now, one thing that is very important to remember is that an isocline is not a solution curve. All it is showing you is where the gradients are the same. It is not showing you a solution to the differential equation. Now, for this reason, it's not always a good idea to draw isoclines and solution curves on the same grid, because it's quite easy to get yourself confused in that sense, because you're going to look at one of your isoclines and you're going to be unsure as to whether it is in fact an isocline or whether it is a solution curve. So one thing that you might like to do is to use a different colour if you ever find yourself having to draw both on the same grid. But a better thing to do is, when you're drawing isoclines, label them clearly, make sure that you know that they are not solution curves, and draw them on separate grids. In this video, you've learned the definition of an isocline, and you've learned how to sketch isoclines.